So I'm going to quickly go through this test, okay, on the recent organic chemistry naming, drawing, isomers, skeletal formula, structural formula, etc. Okay, so just check any answers that you are getting wrong. Okay, correct them as you go along. Any queries or questions you have at the end, please ask me. Okay, so if we look at the first one here, we have a molecule written condensed structural formula. We have repeating CH2 units, and so we have a CH3 at the end. Repeating CH2 units are just drawn out then like this. 1, 2, there are 3 of them, and a CH3 at the end there. So that is simply a straight chain, that's just pentane. The next one is a carbon with bracketed 3 CH3s around it. So we have carbon with a CH3, a CH3, CH3 and a CH3 around it. If we follow the rule of finding the longest unbroken chain, the longest unbroken chain is 3 carbons. And here we have a methyl group above the second carbon and a methyl group below. So that is dimethyl propane. The longest carbon chain is 3 propane. So it's 2 methyls on it, dimethyl. Don't need to write 2,2-dimethyl because the methyl groups can only be on number 2. If we look at the next one, our longest chain is 1, 2, 3, 4, 5, so it's a pentane. We have a bracketed CH3 group here, so that CH3 is attached to there. And that is, if we label from either side, it doesn't matter, that is number 3 carbon that's attached to, so that's a 3-methyl, and it's 5 carbons in the longest chain, so it's 3-methyl pentane. Okay, the next one, we're moving into 1, 2, 3, 4, 5 carbons again. So that's again a pent. We have a bracketed CH3 on this carbon here, which is number 2. And we have a bracketed CH3 on this carbon here, which is number 3 if we label from left to right. If we label from the other side, they are on numbers 3 and 4. So we label left to right to keep the numbers down. So that is 2, 3, hyphen, dimethyl, and what did I say, pentane I think, it was 5 pentane. Okay, this one pretty straightforward, just has a double bond here, so it's all straight chained, 4 carbons in it, double bond is between number 1 and 2, so that is just but hyphen 1 hyphen ene. Down here I told you to get rid of that hydrogen. We have 1, 2, 3, 4 carbons, so we've 1, 2, 3, 4. And then at the end I have a CH3 on this one and a CH3, 2 CH3s on that one, sorry, with a double bond here. So again, if I look for my longest carbon chain, it is 1, 2, 3, 4, and that CH3, one of those 2 CH3s there is in the longest carbon chain, so that makes it 5, which makes it a pent. Okay, we also then have this methyl group here, which is on number 2. Okay, so we have, 2 hyphen methyl pent. The double bond is on number 1 ene. That's actually wrong because this is the double bond is on number 1. The methyl group actually has to be then given position number 4. The double bond gets highest priority, of course. Okay, so some of you might have put 2 methyl there by mistake like I did. Okay, but hopefully you caught yourselves on. Right, then we have to draw skeletal formula, so we have a hept. Okay, so we draw 1, 2, 3, 4, 5, 6, 7. We have a double bond on number 1, so we put a double bond in, or we have an ethyl group on number 3. Ethyl groups are simply that. Okay. Here we have then a but, so we go 1, 2, 3, 4. We have 2 double bonds on number 1 and on number 3. That's how we draw a but. 1,3-diene or buta-1,3-diene. Okay, the next one we have things with 2 functional groups. So here we have an alcohol group and we have a carboxylic acid group. Carboxylic acid groups are highest priority. Alcohol groups has low priority. If you had learnt your table, will become hydroxys. The high priority group gets the lowest number. This is number 1. So the alcohol, the hydroxys, are number 3. So that's 3 hyphen hydroxy. And that is 4 carbons, and that is butanoic acid. Okay. The next one we have this group here, and we have this group. So therefore we have this group here is an amide if you learned your functional groups well, and this group here is an aldehyde. So the amide, is the highest priority, and the aldehyde group is either a 4-mile, or an oxo, doesn't matter, okay, as low priority. So that is 4-oxo or 4-mile. 4-oxo, we have 4 carbons in the chain there, just checking, and it's butane, and it is amide. Okay, amide. Next one is just an NH2 group, not an NH2 group with a C-double-O bond like we had up above. That NH2 group, there's only one functional group in it. It is prop, 3 carbons, propan. It is an NH2 group. They are amines, not amides, remember. Here we have chloros. We have 3 chloros on 2 carbons. So we have chloros come at the start. Okay, there's 3 of them, so it's tri-chloro. And it is numbers on 2 of them on number 1 and 1 of them on number 2. So we have to put all the numbers in. So it's 1, 1, 2 hyphen trichloroethane. Down here we have 2 of the same functional groups. They are alcohols. We have 3 carbons in it, so it is a prop. It is an an. Okay, and it is 2 OH groups. Diol. They are numbers 1 and 3. Okay, and we have a hyphen and a hyphen. Remember this time, because we have 2 of them and our ending starts with a vowel, we have to put our E in there. So it's propane 1,3-diol, that one. Okay, here we have 2 functional groups again, 2 different ones, sorry. We have a nitrile and we have an amide. Now, the highest priority one, if you've learned your high priorities, is this. Okay, the amide one, the nitrile, when it's low priority, is referred to as a cyano group. So therefore we have 4, because the high priority gets the lowest number, which is of course number 1. 4 cyano, 4 carbons in this in total. It's butane, and the high priority group, which gets the suffix, is the amide. So 4-cyanobutanamide, or butanamide. Structural isomers, some of you didn't learn your isomers or definitions very well. Structural isomers is simply when you have 2 things which have the same molecular formula but different structural formula. A geometric isomer then is defined as something that has the same molecular formula but a different structural formula for 1 mark. But that different structural formula is due to the presence of a carbon-carbon double bond. A lot of you didn't make any reference in there to the fact that a geometric isomer has to have 1 or more carbon-carbon double bonds. So you only get 1 mark out of 2 there. Right, draw the structural isomer of this. So a structural isomer, there's a whole load of different answers to these. This one had to be not a geometric, so it was C6H12, so it was an alkene, so it had a double bond in it. Okay, so the simplest one to do here, there were several, but the simplest one to do was just put 2 hydrogens on this carbon here in the double bond. Once you have 2 groups on the carbon and the double bond that are the same, it cannot have geometric isomerism. So my view, that was by far the easiest one. Then you had to draw one which was a Z isomer, so you had to put the double bond in. Okay, and you had to have 2 different groups on the left, so I would have put a CH3 there, okay, and I would have put a hydrogen here, okay, and that left me 3 used up here, so I would have put a C2H5 there maybe, and I would have put a CH3 there. Let me just check if that is C6H12. It is C6H12. It has a double bond, it has 2 different groups on the left, it has 2 different groups on the right. It has to be the Z isomer, so we need to double check that. This is the high priority group on the left, and this is the high priority group on the right, so that is indeed the Z isomer. There were other possible answers to that as well. Okay, this we just had to say whether they were yes or no isomers of hexane. Right, so this one, longest straight chain is that, so that just is hexane, so that's a no. This one here, same thing, longest straight chain, that is just hexane, so that is no. This one, the longest straight chain is there, and we have 2 methyl groups. It's still C6H14, so that's a yes. This one here, if you drew it out adhering to a skeletal formula, you would have come out that that was C6H12, so it couldn't be hexane at all, which is C6H14. So that was a no. These ones you had to decide if they were EZ isomerism. So let's draw them out. We have ethene, okay. We have a 2,2-dichloro, so Cl there. Well, as soon as I draw that, I know that there's no way that this could be EZ isomerism, because it has a double bond, but it has two groups on this particular carbon, two chloros that are the same. So that's a no. This one here, I have ethane, so I don't even have a double bond in this, so that's an absolute no. I don't even need to draw that one out. Here I have butanene, 1, 2, 3, 4. Put the double bond in there. Butanene must have two hydrogens there. So it has two hydrogens on the carbon, one of the carbons in the double bond, two same groups on the carbon. Can't have EZ isomerism. That's a no. Pentene, 1, 2, 3, 4, 5. Double bond is there. Okay, let's draw these in. So if I take this double bond, this carbon in the left-hand double bond, it has a hydrogen and a CH3 group attached to it. That's fine. The carbon in the other side of the double bond has a hydrogen and a C2H5. It also has two different groups. That's a yes. Okay. Let's have a look here. We have butanene. So let's 1, 2, 3, 4. Double bonds on number 1. On number 1, I have a bromo and I have a chloro. So I have a Br and I have a Cl. Well, there's two different groups in that carbon in the double bond. In the other carbon in the double bond, I have a 2-chloro, so I have a Cl there, and I have a C2H5 on it as well, so that's a yes. That has two different groups. Here we had to draw Z isomers of butene, so butene, Z isomer, okay, must have a CH3 there and a CH3 there, hydrogen there, high priority, both on the same side. That's the Z isomer. Here I have to conjure up something a little bit more complicated. I've got C4H6Br, so I'm going to put a double bond in because I'm going to need that end of. Okay, I've got, there's a variety of answers here. I'm just going to put my Br there and my F there. That sorts that side out. I'll put a hydrogen there, and that leaves me with C2H5 left over. Okay, now let me check, that's the Z. So there's the high priority is the bromine, and the C2H5 is the high priority on that side. Again, there were several answers to that. That, I think, is the simplest of all of those answers, in my eyes anyway. May be wrong. Okay, here we had to work out if these were E or Z. So on this one, we had to go to the high priority. So all of this here was no good. We had to go right out to the very end, and it ended up being bromine against hydrogen. So in other words, here we have this one is high priority on that particular side. Down here I have the two carbons I can't use. The next ones out are oxygen. This oxygen is 8, and chlorine is 17. So it's 8 because the oxygen is bonded twice. Antimony, which is SB here, is 51. So that's definitely high priority there. So that is my E isomer. Opposite high priority groups on opposite sides. Okay. That was the hardest one of the three of them, to be honest with you. Here I have, over here, high priority is the chlorine, 9 against 17, obviously 17 wins. And then I have iodine, which is 53, against my bromine, which is 35, so that's high priority there. So my two high priority groups here on the same side, below the carbon and the double bond, that's Z. Here I have chlorine versus iodine, so I have 17 versus my iodine, which is 53, I think. Yeah, okay. So my iodine is high priority there. Here, if I go along here, I can't use those carbons, so I go to the next group out, which is carbon, hydrogen, hydrogen. Here it's also carbon, hydrogen, hydrogen. I've got to go further out again. When I get out to here, I have two oxygen double bonded, so I go 8, 8. And then I also have another oxygen. Okay, so I have 8, 8, 8. If I go to the further out here, I have oxygen and two hydrogens, so I have 8, 1, 1. Okay, so my high priority group is on the bottom here. Okay, so I have high priority on the bottom, so that's the Z isomer, because high priority is also on the bottom on the other side. Okay, hopefully that clears up any mistakes that you made. If you have any queries beyond that, you need to ask me. Okay, and make sure you correct your test and review where you went wrong.